Okay, so this video is on graphing functions in standard form. Standard form is f of x equals ax squared plus bx plus c. This exponent of a 2 here is what makes this a quadratic function, so we know that this is going to be graphed as a U-shaped function. A U-shaped function is also going to have an axis of symmetry, which, as you can see, the vertex is the only thing that will be on the axis of symmetry. And that is something you could fold the parabola into, and it would fold on top of itself. The axis of symmetry is found by finding x equals negative b over 2a. That is also going to be the x-coordinate of your vertex. And then to find the y-coordinate, you would put that in for x and solve for y. This information you've already seen in a previous video. If a is positive, it opens up. If it's negative, it opens down. If it's less than -1 or greater than 1, it's more narrow than the parent graph. If it's 1 or -1, it's the same width as the parent graph. If it's between -1 and 1, it's wider than the parent graph. Alright, so if we try to graph this one, let's first find the vertex. So I'll find the vertex by doing x equals negative b over 2a. As you can see in this problem, a is 1, b is -6, and c is 4. So I would do negative b, which is -6, over 2 times 1. If you clean that up, it would be 6 over 2, which reduces to 3. So now you know that x equals 3 is going to be the vertex, or excuse me, the x-coordinate of the vertex, so that's your axis of symmetry. To find your y-coordinate, you put 3 in for x into the function and solve for the y-coordinate. And that's going to be -5. So your vertex there is 3, -5. So 3, -5 would be here. Now, a couple of things I know about this parabola is that it's opened up because a is positive and it's the same width. So for right now, I'm just going to give a good sketch of that. I know it's a parabola going to look about like that. To find specific points on this parabola, all you'd have to do is plug in numbers. So I could plug in x equals 1, x equals 2, x equals -4, so on and so forth, just as I did here for the 3, and find ordered pairs on that parabola. Okay, the next parabola, or the next function we're going to graph is here. So again, let's find the axis of symmetry by doing x equals -b over 2a. So the negative is there, and b would be 12 over 2 times -3, which that's going to reduce to -12 over -6, which is 2. And then you put 2 into the function to solve for the y. A common mistake there is do the exponent first, and then you can multiply to the -3. Do not multiply the -3 and 2 and then square it. So that's going to give me 13. So my vertex is 2, 13. So 2, now that's going to go off the chart and be up here somewhere. Remember, x equals 2 would be your axis of symmetry. That's coming from this number. Since a is negative, it is going to come down like this. It's not a perfect sketch, but you get the idea. And the -3 also makes it more narrow. So the negative actually turns it down, and 3 makes it more narrow than the parent. As you can see, this parabola is turned down, so this vertex would be a maximum value. And then this vertex would be a minimum value. Okay, now let's go ahead and find the domain and range of these. Remember, the domain of a function of a parabola would be all real numbers. And the range of this parabola is going to always start with your y, and then your range is always determined by the y coordinate of your vertex. So 3, -5, I'm going to look at that number. So -5, and then if the parabola is opened up, you go greater than or equal to, because -5 is the smallest y value I could have, and then it goes up from there. On this one, your domain would be all reals. And then your range, again, y, and then that's going to be 2, 13. So 13 would be part of the range. It's pointing down, so it's less than or equal to, because 13 is the biggest y value, and then it goes down from there. So that's how you graph functions in standard form. And again, if you want more specific values, all you do is put values in for x and solve for y.